So security is everyone's job. Unfortunately for the security team people, they might be the ones that are fired, but the blame does fall on all of us to take care of this issue. And so I'll talk a little bit about that today and a little bit about sort of how you can implement security in a way that makes it easier for not only the security team, but the developers, the testers, and by the end of the day, you have just a more secure product that you're putting out instead of trying to bolt on security at the end. So we want to get away from that mindset and try to incorporate security throughout our software development lifecycle. So we'll talk about a little bit about that. So first things first, security right now, security is hard, right? It requires a lot of testing, a lot of documentation, a lot of time. Well, because there's a lot of testing, a lot of documentation, it takes a lot of time, and because it takes a lot of time, there's few releases. And this is usually development team versus operational team, where the development team is incentivized to add new features, fix bugs, and the operation team is incentivized to make everything continue to operate and stay up and not go down. And so there's that clash, but there's also that clash between the dev teams and the security teams, where the developers want to add features. They have to fix bugs, but more importantly, they want to add the features which could incorporate more vulnerabilities into a product or application or any piece of software. And the security team has to make sure that new piece of code is secure. Now we have to find a way to do this so that we want to make the development team happy and we want to make the security team happy. So as he said, I'm a researcher in DevOps. Guessing most of you could guess what the next slide is about. And that's right, automation. So a lot of people are trying to automate their delivery pipelines, their CI server. They have continuous integration, continuous deployment. They have source control type things, static and analyzers. And we'll go through some of that today. And but not a lot of people are continuously doing security. Like when you hear continuous, you hear integration, deployment, delivery, things of that nature, but you rarely hear continuous security, which is just as important in my opinion, and probably some of you out there. And that's why you're here today. So I'm going to go through a quick, or how we lay out the software development lifecycle at the SEI, which is, like I said, in Pittsburgh. So a project starts in its inception, or a phase of a project starts at its inception. That's where you do your requirements, your design documents, what's this product going to look like when this phase of work is done. And then we work into our project configuration. Now, that configuration has to do with like building environments, what technology stack are we going to use, what each person's role for the piece of software will be, and things of that nature. And then we start actually coding. Now that we have what technologies you're going to use, we can actually start coding. You can't code before you know what your stack's going to be. Well, people do, but you shouldn't. And you commit that code. You do some kind of code review, whether that's automated or peer review or a combination of the two. Then you integrate and test. You deploy and test. You QA and test. It's a lot of testing. And then you transition that software off once you finish it, and then you keep going on that circle. And notice that documentation is right in the middle here. I don't know if you guys can see the word document right there, but that's what that word says. And that's pretty important, right? We shouldn't be doing documentation like here. When this is all done, we're ready to transition, then we have one day to write 14 different documents and try to get this released in a timely manner, in a helpful way for the actual end user. So just a quick, I'm gonna ask for a little bit participation. Don't have to. I'm not gonna call on you. But so what would you guys consider parts of like the delivery optimization? Like when you're actually delivering the software, what parts of this would you, like, what categories would you map into delivery optimization? You can just shout, or you don't have to do anything. Okay, that's fine. So most people, when we ask this question, they say they start in the continuous deployment and QA integration, then we're starting actually the delivery process. Some people even go all the way to the integration step, but very few people actually include the project configuration, which is what we consider, because at the end of the day, you're delivering that stack of technology, and you need, at that point, and maybe even before that point, you have to start thinking about your transition strategy, what it means, what documents you'll need to hand over for the end user to be able to successfully use this application. And then from there you code, you're obviously giving them code, and you're giving them that process of the full process, wow, I just said that again, of how you develop this application and what steps you took. So there's really clear documentation of the steps that were taken to deliver this software. And you can even provide security. And the next slide I'm going to show you is the most important slide in this presentation. This is the slide that I hope everyone takes a picture of, but we'll see. So this is the security slide. Where's security? A lot of security, right? So security this is not doing security right there. That's not doing security, or whatever doing security means is not really even that clear. But trying to bolt on security, doing a bunch of security type tests, penetration testing at the end of the project, at the end of the project, and trying to get everything to work right and to not have any major vulnerabilities at least, and all these things right at the end is going to be, I'm sorry to say, a big problem. So we're going to start in the inception, which is, again, either you go to the customer comes to you and says, I want this. And it might be on an existing product that you have, or a brand new project and at my specific company, we have a lot of these new startup projects. And so usually it's not phases for us, it's usually projects, but it does work with phases as well. Because you have to go back to the requirements gathering, and that's what you're doing in Inception. You do requirements gathering, the design documents, and you can even do things like threat modeling, and these things that security team people might be doing, but they're not at all part of this. They're not incorporated into this actual, the security or the design documents have no bearing on what the threat models say. So the take-home message today is security, and back me up, security people, because I think especially you agree with this, that you guys want to be a part of the project here, right? You guys want to know what's going on. You want to know what the stack is, because then you guys can prepare for it. You can bring up information that's needed, say we're doing a typical LAMP stack and they want to use a very insecure version of PHP or whatever. And you can say, wait, you should use this version instead, or just, you can get out ahead of these things so you don't have to be right here and be yeah, you can't do that unless you have these 40 patches. So if you move this to here, it makes this process a lot easier. So that's sort of what we're getting at with this, to get security left, as far left as possible. Get your security team involved, get your testing team involved, get your managers, your business people involved, and obviously the developers will be involved in this process. It's the development life cycle. So then you start coding, and the one thing that people actually probably think one of those red circles should be around is coding. You should be your coder should be writing secure coding, and we're making a assumption, and mostly because it would kill us a little bit on the inside if we didn't think that developers always wrote secure code, or at least try to write secure code. So we don't even mention it here, but obviously secure coding is important, and that's the kind of stuff that can be caught in the code review for new developers or someone that just missed something. Even as simple as checking input. And So we want to start automating this, right? Because adding all this work on each of these steps could consume a lot of time and make the inception or the design and requirements process much longer than it usually is, and really affect what you're able to give to the customer at the end of the day. So we have to start automating somewhere, and why not at the code review? You can automate some of this stuff, definitely the documentation. A lot of these tools and stuff you can start automating automatically and generating security documentation from the beginning. But some of the things, I'll show you a demo later today where we actually do, it's a static analyzer for, just happens to be Ruby on Rails, but it doesn't even allow you to commit your code to the code base unless it passes the static analyzer. So there's stuff like that that you can do, and it'll help your developers learn and develop more quickly in more secure ways. So that's one possible place. The next place is the continuous integration, which is the second demo today. And we'll talk about what types of tests you can do at that time and how you can write scripts in a manner that allow them to be repeatable. So you just add them as build steps almost to run a suite of these security tests. And while doing all this, you're just building a confidence with your developers, your testers, your security people, your managers, and your customer that we're actually developing a piece of software in a secure manner. And that's why, so continuous deployment, and then again, the QA integration where a lot of security testing is usually done. So so you'll continue to do security testing there. And then the historic thing is just it's instead of a huge security undertaking, it's now just a security review and acceptance testing, a security acceptance testing. And it just takes a lot of the work that was done historically right here, and it pushes it into all these areas. And we're actually doing research right now on how much money this will actually end up saving you, because you don't have to finish a product 2 months early if not even earlier than that, to run security tests, and then from the fallout of that, redo a bunch of this stuff. So we think that there's a very good correlation, positive correlation between how much money you'll spend and how much security you did before you get to the end. All right, so again, this is the idea of pushing security left, and this was brought up in a paper by Ben Tomhave and Sean Knifick, maybe, in Gardner Research. The paper's entitled "Security in a DevOps World." But it's this idea of what I was just explaining, pushing the security left, making the security team aware of what's going on, your developers aware of what's going on, so you're just always thinking about security. And breaking these down into these manageable tasks just makes it so much easier, and your developers are able to learn what's going on instead of just trying to fix a bunch of things because the security team flagged a bunch of things. And there's these like give and take type situations. And some of the benefits that I have not yet mentioned, because there have been a few already, but you get shorter feedback loops because you're doing it all the time. Like, if the static analyzer fails, that's a feedback loop you have. You can fix the code right there, which creates team efficiency. And since you have the feedback loops and the efficiency set up, you can more quickly deal with incidents once you're in operation. And because it's not this one big glob of security, there's actually traceability throughout the process, which is huge in some of those things. So there are a couple of downfalls to doing, or some cons, some not so great things about doing DevOps and security, because it's not just the application security anymore. If you have all these boxes set up, writing a really secure application or piece of software means nothing if someone can hack into your continuous integration box and just rewrite your code, right? So not only do we have to worry about application security, but we also have to worry about our environments, because we could have, N boxes of hardware and because that's the point of DevOps. We're just spinning up hardware in a very automated way, and that's sort of where we're going with this. But we have to make sure those environments are secure, as well as the application that are built on those environments are secure as well. All right, so again, automate, do it. So it's huge. You can, just to reiterate a little bit, you can run a suite of security tests at any time. And of course, the tests have to be written in a repeatable way, which there are several tools being developed and are currently available that you will see that do allow this already. So, I mean, take advantage of the technology that exists already and leverage it for whatever you need it to be leveraged for. Again, the feedback loops, they not only do they allow you to be continually test, but the developers and the testers get that feedback quickly, and they understand what's going on. They can fix things more quickly, and just makes for a better learning process for your entire group, your development team, which is not just developers. So we're going to go into some demos now, so you can actually see some of the tools involved. All the tools that I will show you today are open sourced. So you'll see static analyzer, like I mentioned, that checks for simple secure coding principles. Today I'll show you it failing on, I'll show you, but it's on hard-coded log credentials in your source code. So if you do that, don't do that. And then the second one's security tests written for, that can be written for your piece of software or for the environment, and that runs in your continuous integration server. So it just gives you a little bit more insight of what's going on in your total life cycle and the total health of your piece of software. So what is automated static analysis, or what is static analysis? It just, I mean, without running your code, it allows you to check for certain things, and it's usually done with regular expressions for specific languages because they know what to look for. Why do it? Why not? Since we can automate it, it's almost free, and it gives us really good feedback, and the developers can really learn from this. Definitely when you bring new people on from out of school and or switching industries or something, new to the field, but they might not think about input validation, because a lot of the newer languages, you don't really have to do that as much as you used to in like C, for instance. So some of the tools, Breakman, which is the one I'll show you today, Ruby on Rails, DevBug, which is a PHP static analyzer, Visual Code Grepper, which does, as you can see, several coding languages, and these are all open source. There are a slew of other ones that allow you to, or static analyzers, both open source and commercial, so please don't think that's an exhaustive list at all. Now, does anybody use Breakman? No. Does anybody write Ruby on Rails applications? A couple? All right, so, whoops. And then, so anyway, I mean, you'll get the idea of what I'm trying to say here still. So Breakman, like I said, is a static analyzer that's specific to Ruby on Rails. Most of them do focus on one or only a few technologies, but some, like the one I showed before, have a slew of them. But so I'm going to show you today not only how Breakman works. Breakman's a command line tool that you just run. It's a gem. You run it in the root of your project, and it just gives you some output that tells you if there's any security issues involved. So that part itself, in that situation, developers would have to run Breakman themselves and then commit the code. So instead of relying on them to do it and being honest with what they're doing, we're going to use Overcommit, which is another open source tool that is a pre-hook for Git that we can use to, so right when they try to commit, it runs certain tests, and before they push, it runs certain tests, and it can block those if those tests fail. So both of these tools, Breakman and Overcommit, are really easy to configure and very customizable. You'll see Overcommit has, they have a lot of built-in tools to use, including Breakman. So I'm going to get out of here and start to show you this a little bit. This is the more interactive demo. Okay. Whoa. All right, so don't mind that. So this is, I'll show you the app, but if you go to like beginner Ruby on Rails, if you like type that into Google, they have you build this like little blog app. So I'm actually kind of glad that a lot of you are not big Ruby on Rails people, because it's just a really simple example instead of a long, big, convoluted thing that we can easily kind of digest what's going on. So obviously you create a new article, you see the articles that were built, you can show, edit, destroy. It's just simple CRUD type things that to help you get into the Rails. So I have this on my GitHub. I committed it to my GitHub, and I'll share that link with you at the end of the presentation. But so yeah, so it's just simple. Everyone can kind of understand what's going on. There's no authentication going on, so that's where we'll break things. So let's run it now with no authentication. And since so you can just run Breakman, and you can see that there's like no security warnings because, well, it's a very bare bones app. There's not much going on. You don't have to have authentication because there's no real database. You're going to hack. There's no people or personal identification. You're just going to steal blogs that you can already read. So, but so now I made a small change, and I'm going to commit that change just so you could see what Overcommit does. Oh yeah, didn't even mess up that typing while everyone's watching me. And you'll see, most people know what the git commit looks like. It's just like one line, but this is slightly different. Oh, I forgot to add it. So you see it goes through these certain commit message hooks when you try to commit, and if it fails on any of these, it will not let you commit code. Now you could skip that if you have to push something through, but in the everyday world, like that's really nice. And Breakman does not run in this context. It runs when you try to push. So I'm going to push real quick. Hopefully I'm connected to the internet. So you'll see, oh, please don't go away. Breakman, it ran for the security vulnerabilities, and Breakman returned with an OK status. So it's nice. And if it would have failed that, you would have seen, like this never would have happened. It would have aborted. So I'm going to break it just so you can see what happened. So now I'm doing, oh, that's hard to see. Basic authentication with Rails. It's pretty easy. But notice that my username is user, password is secret, and I have that in my source code. So anybody could just see that and do whatever they wanted anyway. So that's not good. So now we're going to try to commit that. So git commit bad auth. Okay. So you'll see that the pre-commit ones still work. But as soon as I try to push to master, that wasn't supposed to happen. I didn't save it, so sorry. I'll make sure it changed. Okay. Sorry, everybody. Okay. All right. Oh, not today, everybody. Not getting past me. Woo! All right, so as you can see, and it gives you a little bit of output of why it failed, and that was annoying. And it does say somewhere, and then you can like run Breakman if you wanted to, and it'll actually tell you right here, if you could see it. Well, take my word for it that it says it right there. But it says bad authentication password stored and whatever. It tells you what controller that's happening in, the warning type, and if it's sure or not. Now, there are some things about Breakman that you should know. It is suspicious, so more times than not, it will trigger a warning or a security problem if it's at all thinks that something might be going on. So just be aware of that. But that's probably not necessarily a bad thing if there probably is something going on that may just need to be changed a little bit, or it may or may not be able to be ignored. But yeah, so that's Breakman and Overcommit. And you can use, I'll just talk about it. So Overcommit has a YAML file that you can work in and you can enable a bunch of these types of technologies. And so I had to enable Breakman, but there's probably close to 80 technologies that can be used in Overcommit that's just preloaded. Plus you can add your own automated, any kind of command line, anything. You can add to it yourself and it'll run it by itself, which is it's a really, really flexible and nice tool. I highly recommend using it just because it'll at least get the simple things, if not more complicated things as well. Depending on which technology you're using, you can decide on that. So the second demo, where am I in time, by the way? So I guess I'll start this back up. Okay, that's what I figured. And so the second demo is about automated security tests. Now these are your penetration tests, your vulnerability scans, your security scans, and I believe that the next talk has to do with more of this, right? Yeah, okay. So if you stay around, you'll get a probably much deeper, better description of this stuff. So this is more high level than most. So what are they? They're penetration tests, vulnerability scanning, security scanning, kind of general things that have to be done anyway that we can automate. We can use tools to do that. So why do it? Again, if we can automate it and it's not that expensive, why not do it? We get good information, we get good documentation from it, and we get knowledge for the developers, the testers, the security team, the managers, so they know the state of the current work. So this demo, I'll be using Gauntlet, which is, well, it's on the next page, and OWASP, or there are a couple tools you can use, Gauntlet and Zap, the Zap project. And OWASP is pretty big in the application security world. You probably have heard of it. But yeah, so this time I'll be using Gauntlet, which is it integrates with existing security tools, mostly command line, like Nmap, SQL map, slot, or SSLIs, or however you say that. Arachne, which is a cross-site scripter thing. You use plain English language, and I believe they did this to help people that do penetration tests, because it's kind of, even in the Gauntlet language, it's formatted like, I want to run this command, and the output should be this, and then checks it under that, and it's the Gherkin syntax under the Cucumber framework, or I think is the technical things behind the plain English language stuff. And it integrates it really easy into build servers. And the build server I will use today is Travis CI, which is open source. It has hooks into your Git repos that you can use, and it just checks the Travis YAML for what steps it needs to take to build this stuff. So that's what I'm not actually going to run it live just because it takes a little bit longer, but I'll show you sort of what it looks like, what the attack files look like, and what the output is for that specific test. Okay. Oops. All right. So that is not easy to see. Can everyone still see that? Oh man. Oh, this all got messed up. Okay. This might not. Here, I'm just going to go because it shows you in the Travis CI stuff too. So, oops. Still good. Okay. All right. So now we're just a simple tech. So you have to give it a background. So you have to make sure Nmap is installed, which is your kind of your port checker, and you have to give it a host. And then the scenario is I want to make sure the server is open on expected ports, and it runs. This is localhost, so it runs a little like Rails application or something like that, and checks to make sure that we have that port open, that we can actually access that application. Now, I won't go through all of these, but so there's this idea of being able to create environment variable names, and this is kind of what this is showing. It's the same test actually, but showing using environment variables. That way you can even automate this more into your test environment, your staging, and probably don't want to test in your production environment. So as you can see, like this is actually what you're typing in. When I launch an Nmap attack with whatever command, the output should have that in it. And if it does, it parses the output, and if it has 8008, which is whatever the port they decided to run the application on, that's all right. So then you can also check like here. So this is an example where we're testing the actual build server, not an application, but the actual build server, because we want to make sure that's secure too. We're going to make sure that we don't want any, actually you probably do, you may want emails coming out of your build server, but say in this case you don't. But we want to make sure that is actually closed. And that's pretty important because like we don't want anyone to be able to exploit a vulnerability that we don't even know is there because for whatever reason, by default, the mail port was opened for some reason or something, or someone accidentally did it. It doesn't really matter why, but we don't want it to be open. We can check to make sure it's not open pretty easily. And then a more interesting thing, look into a URL is, like we're actually gonna now use a cross-site scripting called or command line tool called Arachne. And we wanna hit our application with an Arachne attack with these options, and we want to make sure there's no issues detected, and there weren't, so we pass this. Now, if say this gave us one issue, like this would fail and actually fail the entire build. So our test environments wouldn't even get this code, and we could quickly figure out what's going on. We could go through this file, this log, and figure out, oh look, this failed because of whatever reason. Let's figure out what's going on, fix it, and then build again. It works, great, we can deploy. Or it allows us to deploy rather, instead of, yeah, so that's, I think, all I have for you guys. I'll get back into here. Oh, well, my conclusion. So, in conclusion, automate, push left, a lot of things good, very few things bad. Be happy, live a good life. Thank you. Take any questions. My demos and slides will be on my GitHub. This is my blog, which I talk about DevOps security. And if you go to the DevOps blog in insights.sci.cmu.edu, you'll see my colleagues that are writing about configuration management, all those fun things too. The rest of DevOps. My emails, work email, personal, Twitter, which I'll post at least my GitHub URL on my Instagram or my Twitter, so you can go back to that whenever you feel necessary. Any questions?
The software testing has like unit testing, integration testing, system testing. So maybe security testing should be in that ladder too.
Yeah.
Test ladders.
Yeah, I think, yeah, instead of, like we've already moved the rest of the testing throughout the development lifecycle, why not move security type testing too? Sort of our point.
So the testing, security testing at the unit level different from the integration level and system level.
Yeah.
How are they different?
So, well, that's a good question. I guess you're just kind of looking for different things. So in the security tests, I mean, you're testing, I guess they're not, like system tests and unit tests are separate, and security tests can be unit tests, can be system tests, can be different types of tests, but they're just looking for different things. And I think that would be sort of the difference between them all. Does that make sense?
Yeah.
Okay. Anybody else? I saw a couple other hands. Go ahead. I think your hand was up second.
You had a trigger on the Git command, and you mentioned that the tool was a bit sensitive.
Yeah, Breakman, yeah.
So that leads to the issue of you can desensitize it by circumventing the test in the code.
Right.
So how do you prevent, you prevented the push, but how do you prevent the
skip
developer from circumventing
Right.
the security test in total?
So, I mean, we're obviously not going to have people, it's not the only way to find these things. And we're obviously not going to have someone sitting over their shoulder to make sure they actually follow the thing. But it's kind of more of a building the development team around the idea of writing secure code and getting them on board with that. Like instead of just trying to get past another step, they'll want to actually fix it and write secure code. And it's kind of like more of a culture issue, I think, than it is like hammering on people. And in code, I mean, you still have to do some manual labor to get this stuff. And if you notice someone keeps doing or committing stuff that should have been caught by a static analyzer, you can address that as you see fit.
Yeah, the other aspect of that, the value of static analyzer isn't necessarily how verbose it is, but how intelligent it is to actually pluck out real issues as opposed to throwing lint at you, basically.
Right.
So I'm wondering, as far as the open source tools, are there tools that have a good suite of tests, a broad coverage, and are also intelligent enough not to barrage you with user data?
Yeah. So, of course, there are probably more of the commercial ones, or you can more guarantee that type of thing. But there are commercial ones out there, and I do believe Breakman is a pretty solid example, and that's why I gave it as an example. They have really good documentation, and this is the kind of things that I look for when I'm trying to pick these tools is, do they write good documentation? Do the contributors to that actually care about this product? And I think that's sort of gauging off that is how you can tell if it's a simple like lint type of thing or a more advanced type of almost commercial but not type of thing. I think I mean, you just have to figure out which ones are which, I guess. It's not an exact science, but it can happen. And
my question was similar in that, do you know if the client static analyzer that supports security-specific tests?
which one?
Client.
I do not. I do not have direct experience with that. Sorry. Any other questions?
Oh, that's good. In Breakman and other static code analysis tools, what are kind of the top 10 things they should be looking for, like, typically?
So I would say like this one, like the example I showed you, hard-coded login credentials, which sounds kind of funny to say that, but that's actually a big problem. Like people, and not necessarily in the context I showed you, but in like more configuration type scripts, they still, instead of using either environment variables or encrypted keys or whatever, they just write it in and hope nobody notices. So it will catch things like that. I'm trying to, like, input validation is something you want to make sure. Sort of if you go to it's 24 Deadly Sins of Software Development or something like that. There's a book that it's like the 24 low level. So you'll want to, like, you want to get those covered. And that's like SQL injection, cross-site scripting, and that kind of stuff.
And CVE.
Yeah, and then CV, yeah, okay. So, yeah, the
Common vulnerability.
enumeration, yeah, that's what it is. Which gives you a good list of what vulnerabilities exist and which types or which versions and of technology and stuff like that. I'm sorry, that's, yeah. Yeah.
So do you work with the CERT secure coding standard?
Yeah, I actually work in CERT. So, yeah, that's the coding standard that we write to, but I think we're trying to move away from like these standards that developers hate and this more of an environment of security matters. And how are we going to make our lives easier by writing more automated security? Anybody else? Okay, think we're good.
All right, thank you.